Hi everyone. Previous lecture we will discuss definition of gamma function and we'll discuss some property. Okay. So in this video we will proving this property. Okay. This property. So first property is gamma n plus 1 is equals to n gamma of n is equals to factorial n. So we proving first. Okay. So so we know from definition we have what gamma of n is equals to 0 to integration over 0 to infinity e to the power minus x to the power n minus 1 dx. Actually first video we discuss it. Okay, factorial n is equals to integration 0 to infinity e to the power x to the power n minus 1 dx. Okay, so here we see our first term is n plus 1, so we choose n is equals to n plus 1. Let n equals to n plus 1, then this term will be changed. Okay, so gamma of n plus 1 is equals to 0 to integration over 0 to infinity e to the power minus x to the power, if we put n is equals to n plus 1 then it will be n dx. Okay, so now we integrate this integral through by parts. Here we choose this one is first and this one is second by use of LEC rule. Okay, now we by parts this and we get x to the power n 0 to infinity e to the power minus x dx minus integration 0 to infinity we derivative this. Okay, so n x to the power n minus 1 into, if we integral this we get e to the power minus x minus 1 dx. Okay, so this will be xn e to the power minus x 0 to infinity minus 0 to infinity n x to the power n minus 1 e to the power minus x minus 1 dx. Okay, so if we putting this value we can first we say anything power infinity, anything power infinity is infinity, anything power minus infinity is 0, and anything power 0 is 1. So here x to the power infinity means this is infinity, and e to the power minus infinity, that means it will be 0. So first term is 0 minus x is 0, so both term are 0. Okay, so this will be 0, and here minus 1, minus 1 if come this side then it will be plus 0 to infinity n x to the power n minus 1 e to the power minus x dx. Okay, So here n is constant term, so we move this term over integral sign. X to the power n minus 1 e to the power minus x dx. Okay, now here definition comes. At earlier we consider gamma of n is equals to integration 0 to infinity e to the power minus x to the power n minus 1 dx. Here this term will come. So we put this definition gamma of n. So therefore n into gamma of n. So first one is proved. Okay, so now we prove, actually this is proved. Now we proved n gamma n is equals to factorial n. Okay, so we know actually little bit time ago we proved gamma of n plus 1 is equals to n gamma n. Okay, so now n gamma n means we can write n into gamma of n plus 1. This term will write with this process n plus 1 minus 1. Okay, so now if we use this term n, sorry, if we consider n plus 1 is z, then it will be gamma z minus 1. So if we apply this property again, then we can write n into, sorry, this will be n minus 1, this will be plus, because here this is plus, okay, not minus. So we can write, okay, n minus 1 gamma n minus 1. Again we write with this type of form. Okay, so n into n minus 1 gamma of n minus 2 plus 1. Now we able to apply this formula. Okay, so we get n into n minus 1 into n minus 2 gamma of n minus 2. If this process runs so many times, then we can get actually this process repeatedly goes. Okay, so at last stage we get n into n minus 1 into n minus 2 into n minus 3 and so on. And we know factorial n is equals to, actually we know factorial n is equals to, we read in class 11. Okay, this n into n minus 1 into n minus 2 into n minus 3 and so on. So we can write this will be factorial n. So we can write n gamma n is equals to factorial n. So we prove second one also. Here we prove this. Okay. So our next property is integration 0 to infinity e to the power minus kx x to the power n minus 1 dx is equals to gamma of n divided by k to the power n. Okay, so we prove this one. So here again we use property. What is the main definition of gamma function? um, Definition is gamma of n is equals to integration over 0 to infinity e to the power minus x to the power n minus 1 dx. So this is the property. Okay, so now we here we can see uh, actually what is the question is integration over 0 to infinity e to the power minus kx x to the power n minus 1 dx. Okay, so here we put kx is equals to z and we put kx is equal to z because we our mission is we our mission is um, we actually find a single term of exponential term. Okay, so we put kx is equals to z, and if we differentiate it then we can get dx is equals to dz by k, and limit should be xz. So if x is equals to infinity then z is also be infinity. If x is equals to 0 then z is 0. So limit is not changed. Okay, so now 0 to infinity, here we put kx is equals to z, so e to the power minus z into, if we put x is equals to z by k, here kx is equal to z, then we can get x is equals to z by k. So x is equals to z by k to the power n minus 1 dx. So here k is constant, so uh, we remove this term out of integral. Okay, so 1 by k to the power n minus 1 integration 0 to infinity e to the power minus z to the power n minus 1 d, sorry, this is dz also. Okay, so dz. So now here if we apply this property then we can get what, this is not matter what is the variable. Here the variable is z, but here the variable is x, so not matter. Okay, so we can write simply, we can write 1 by k to the power n minus 1 gamma of n. Okay, so so you can write integration 0 to infinity e to the power minus kx x to the power n minus 1 dx is equals to 1 by, sorry, here dx is equal to, here dx is equals to dz by k, so here will be dz by k, and here also dz by k. Okay, so here k will be multiplying, so we can write k to the power n gamma n. Okay, so we can write, so our our property proved. Okay, fully proved. Now we go over next property, that is integration over 0 to 1 x to the power m into log x to the power n dx is equals to minus 1 to the power n divided by m plus 1 to the power n plus 1 into gamma of n plus 1. Okay, so so to prove this, we consider log x is equals to minus z. So therefore, if we differentiate it, we get 1 by x dx is equals to minus dz. Okay, and here x will be e to the power minus z. Okay, and limit should be here variable is x and z. If we put our upper limit x is equals to 1, so if we put x is equals to 1, then log 1 is 0, so this will be 0. And if we put uh, x is equals to 0, then log 0, which is undefined. Okay, so if we when x is equals to 0, then it will be infinity. So now 0 to 1 x to the power m log x to the power n dx is equals to limit, what are the limit 0 to infinity, and x to the power m, what we get, x is equals to e to the power minus z, so e to the power minus z to the power m and log x to the power n. Here log x is minus z. Okay, so minus z to the power n d, and dx is here, dx is minus x dz. Okay, and x is e to the power minus z, so minus e to the power z minus e to the power minus z dz. So here we can write dx as minus e to the power z into dz. If we alternate this limit, then we can get, if we change the term, okay, so then minus 1 will be multiplied with this term. Okay, so infinity 0, and then this minus and this minus will be plus. Okay, so e to the power minus z to the power m minus z to the power n e to the power minus z dz. Okay, so 0 to infinity e to the power minus z m plus 1 minus z to the power n dz, and 0 to infinity minus 1 to the power n into e to the power minus z m plus 1 z to the power n dz. Now we consider z into m plus 1 is equals to t. Therefore, dz is equals to dt m plus 1, and limit should be z, when z is infinity, then t is also infinity. When z is 0, t is also 0. So infinity to 0 minus 1 to the power n, and this will be e to the power minus t, and z, if we put if we change the variable z to t, we can put also z is equals to t by m plus 1. So t divided by m plus 1 to the power n dz. So 1 divided by m plus 1 to the power n, integration 0 to infinity minus 1 to the power n e to the power minus t to the power n. Sorry, this is dt. When we change dz to dt, then it will be dt by m plus 1 t to the power n dt by m plus 1. So now integration over 0 to 1 x to the power m into log x to the power n dx is equals to 1 divided by m plus 1 to the power n to 0 to infinity minus 1 to the power n into e to the power minus t to the power n dt m plus 1 t m plus 1. Okay, so now constant term will come outer side. So here m plus 1 to the power n plus 1, 0 to integration 0 to infinity minus, this will be minus 1 to the power n. Okay, so here e to the power minus t into t to the power n dt. Okay, so minus 1 to the power n m plus 1 to the power n plus 1. What is the definition of gamma function? Definition of gamma function is e to the power, here definition of gamma function we write here, e to the power, gamma of n is equals to integration 0 to infinity e to the power minus x to the power n minus 1 dx. So here we here we find the term n minus 1. Okay, means minus 1. So here e minus t and t to the power n plus 1 minus 1 dt. Okay, so this comes minus 1 to the power n m plus 1 to the power n plus 1 into gamma of n plus 1. We apply this definition. Okay, here and we get actually integration 0 to 1 x to the power m log x to the power n dx. So this property proved. Okay, so upcoming video we proving this value, this all values. Okay, so hope you enjoying this video.